Hello everybody, my name is Mike Geig. In this video we are going to look at part 2 of my mini-series on object-oriented game development. The code I'm going to start with is the code that I finished the last video with. So basically just stopped the last video and started this one. So if you followed the last video, you will have all the source that you need for this video. What we're going to do in this video is we're going to go ahead and create our game object class. Our game object class is going to have all of the functionality that all of the objects in our game will have. So in object-oriented programming, we're going to call this class the base class. This is the most generic class that's going to exist inside of our game. So I'm going to come over here to my header files and I'm going to do add new item, and I'm going to add an H file named game object. Great. Okay. Now, a class in C++ or in any language really, a class is basically, I guess one way you could think of it is a class is like a noun. All right. Anything that you can have, any person, place, idea, thing, could be a class. All right. We can make a class for dog or mammal or human or trash can or tree or car or whatever. And a class is going to contain all of the attributes or member variables that describe the class and all of the methods or capabilities of the class. Okay, so long story short, our class object is going to be comprised of all of the things an object can do and all of the things that describe an object. Now, it's important to note that the game object class is an idea. It's not really anything we can work with in our game or in the code. We have to create an object of that class, very much like when we create objects and variables, and we need to work with those objects that we've created. If you don't know pretty much anything about classes, it's a really good idea to do some learning on the internet, learn a little bit about object-oriented programming before you attempt this. If you know a little bit about object-oriented programming, or if you're confident you can pick it up along the way, more power to you. But basically, we're going to be making templates of things, all right, or game object, comments, bullets, and then we're going to be creating instances of those things inside of our game and working with them. All right. So if you saw the previous series on the 2D game development where I use structs for everything, you pretty much have an idea how this is going to go. The structs had a lot of attributes, if you will, variables that defined or described the struct, but this is going to include methods. It's going to be much more well-rounded. So, since I'm working with an H file, the first thing I'm going to do is I'm going to do pragma once. In my previous video, I explained what that does. Next, I'm going to include some things. Now, I'm going to include a few files here, and interestingly enough, because I'm including them in my GameObject.h, everything that's going to inherit from my GameObject.h, which we'll talk about here in a bit, will automatically get these. So I don't need to worry about adding these to everything that I think needs them. I can just put them here and then everything else will get them. So I'm going to have my Allegro 5.h, and I'm also going to do include and Allegro 5 and Allegro primitives.h. Now I'm doing the primitives because of my bullets are going to be primitives, and also in case I need primitives in any of my other classes, I'm just going to declare this at the lowest level. By declaring it, or by including it at the lowest level, all my higher levels, all the things that inherit from this class, will automatically get it. Alright? And then I'm also going to include my globals.h, just like that. Okay, so this is code that you're only going to see here in this game object.h. It's going to include all these things for us. Alright. To create a class, the keyword is class. I'm going to do class game object, and so the name of my object is going to be game object. Now, game object is going to have all of the functionality that every object in my game will have. Okay, so if we think about very specifics, how like the ship will animate, or how the comets will animate, they're different, and so we're going to have them in their own classes, the animation in their own classes. But there are some things that tie all of these objects together, and those are going to be here in my game object, so I don't have to type them out in every single every single one of my classes. If you'll remember, or if you go back to the struct version of the game we made, remember all of the init functions that had pretty much 99% of the same code in all of them, you know? We're going to do away with all that by declaring it and writing it once here. We have security. Oh, by the way, don't forget a semicolon there, or else you're going to have some infuriating errors later. We have some security. We're going to have some things that are private, some things that are protected, and some things that are public. Long story short, private variables are accessible only inside of this class, inside of GameObject. Protected is accessible only inside GameObject or any object that it directly inherits from GameObject. I'm sorry, directly or indirectly inherits from GameObject. And then public is usable by everybody. Okay. So if you want to know more about class security, you know, there's plenty of information on that on the internet. Now, there are some things I want to be private. Okay. The private things I don't want to be able to be directly manipulated from anywhere besides inside my GameObject. I don't even want my spaceship, which will inherit from my GameObject, to be able to access these directly. I want them to use the accessor methods I'm about to declare. Alright, so private is just that. It's secure. So I'm going to do int ID. So our ID is going to be private. Bool alive is going to be private. That's whether or not it's alive. And bool collidable. Awesome. Okay, so those are my private variables, my members, if you will. Now let's talk about more things that everything's going to have in common. Everything's going to have a float x and a float y and a float velocity x and a float velocity y and an int direction x and an int direction y and an int bound x and an int bound y. And not everything is going to have animation. However, enough things will have animation that I'm going to declare them here. And the one thing that doesn't have animation, the bullets, I'm just going to ignore these variables. I found that that was the easiest way, as opposed to having these specific animations just over and over and over and over again retyped out. So I'm going to do int max frame, int per frame, space would help, just like that, int frame count, int frame delay, int frame width, int frame height, int animation columns, and int animation direction. Alright, and then finally Allegro bitmap image. Once again, not everything is going to have an image. Bullet is the only thing that doesn't have an image, since everything else does. I am declaring it in here, and I'm just going to ignore it in the bullet. Alright, so these are all the things that describe every one of my game objects. Their positions, their velocities, their directions, their bounding boxes, their animation, their images, their ID, if they're alive, and if they're collidable. Alright? Now let's talk about what this object can do. Alright? First off, I'm going to declare my constructor, and we'll talk here in a little bit what the constructor does. I'm not going to have a destructor, but I am going to declare a void virtual destroy. Alright? And I'll explain that here in a second. I'm also going to do a void init. My init's going to take a float x, float y, float velocity x, float velocity y, int direction x, int direction y, int bound x, int bound y. Okay. Then we are going to have virtual void update. Oh, I guess I do want these to all be the same, so I'm going to do void virtual update. And I'm going to do void virtual render float get x. And what I'm going to do is I'm going to declare this one inline. You're going to notice I don't have any definitions for these. In my H file, I'm just going to declare them very much like I have the prototypes of my functions in the main file. in my H file, I'm just going to declare the functions, and in my CPP file, I'm going to define them by giving them actual code. Except for my get and set methods, like get x, get y, set y. They're such small functions, I'm going to do what's called declaring them inline. So they're all going to be on the same line. Basically, it's just putting the definition with the declaration. So my get x is going to return x. Alright? And then my get y, I bet you can guess what that one's going to do. Float get y is going to return y. Great. Do that because I like them to line up. They're prettier that way. And then I'm going to do void set x, and it's going to read in float x, and we're going to do game object x equals x. Okay, let me define that here, or explain this a little bit. Normally, I couldn't just say x equals x, because the compiler would have no idea what x I'm talking about. Am I talking about this x, or am I talking about this x? All right. This x is local to the scope of these two brackets. This x is, I guess you'd say, it was global to the class. Right? Normally what you would do is you would name this something other than x. Alright? You can give this any name you want. I could call it LX for local x, or underscore x, or x2, or x1, or whatever. I could give it any name I wanted to. However, my IntelliSense, when I'm typing and I type set x and then open parenthesis, it's going to say x. Alright? And I like that. I like the user to be able to say, oh, they want an x value here. And so I left it named x. We're going to have the same problems here, where we're going to have to determine if this velocity x is this local velocity x, or if it means this velocity x. So what I do is I tell it. I say game object : x. That means this is the class's x, this is the local x. And so now it's fine. It's taking the local x, the one that's passed in, and assigning it to the x that belongs to my object. Easy enough. I'm going to do set y, and that's going to read it a float y. And once again, I'm going to say game object compound y equals y. Alright, great. Then we are going to do, I'm only using or creating the get and set methods for the variables I'm going to need get and set methods for. Normally you'd create get and set methods, which are called accessor and mutator methods, for everything, but I'm not worried about that right now. So I'm going to do int get bound x, and that's going to return bound x, and I'm going to do int get bound y, and that's going to return bound y. Then I'm also going to do int get id, that's going to return id, and then I'm going to do void set id int id, and I'm going to say game object id equals id, just like that. A lot of repetition. And then getting there, we're getting there slowly. I'm going to say bool get alive. That's going to just tell me if the object is still in game, it still should be updated and stuff like that. I'm going to do void set alive bool alive, then I'm going to say game object alive equals alive, just like that. And then bool get collidable returns collidable, and void set collidable by now. Should seem pretty obvious what I'm doing here. Great. Couple more. Okay, so we have our three game loop, our three main game functions here. Everything needs to be initialized. Everything needs to be updated. Everything needs to be rendered. Okay. We have our constructor, and we're not using a destructor, but we're using something similar, which is going to be destroy for us. It's going to clear up memory and things like that. We have accessor and mutators, get and set methods basically. Some people also call them properties. You hear that a lot in C#. Either way, these allow us to manipulate data directly manipulate the data of the members. And now I'm going to write some function code here. It's going to make things much easier for us. So I'm going to write bool check collisions. Well, that's not right. Check collisions. Okay, and that's going to read in a game object pointer called other object. And what this function is going to do is it's going to read in an object and tell me if the two are colliding with each other. All right, and then we're going to have void virtual collide or collided. I'm sorry, void virtual collided. And what that's going to do, it's going to read in int object ID. After we've determined we've collided with something, we're going to call this function and we're going to tell it what we collided with, and we're going to let it handle that however it wants to handle that. And then bool collidable. And bool collidable is going to be, it's not going to be the same as get collidable. We're going to determine if we should be able to collide with this object based not only on whether or not the collidable flag is turned on, but also if it's alive. All right. So it's one step for, it's like combining this get alive and get collidable into one function, which I'm just calling collidable. All right. Is this object collidable? Is it alive, and is it quote unquote rigid, so that we can have collisions with it? Awesome. So these are all the things in our class that we now need to implement. I see that I'm already quite a ways in this video. I'm going to go a little bit more. We put a lot of work into our game object because it's the basis for every other object. You're going to see that every other object is going to be really, really, really easy to make because we put so much time and thought into our game object. By the way, when I start writing the other objects, that's when I'm going to explain this virtual here. So if you're wondering, you're thinking, hey, he didn't get to that, I will get to that, I promise. All right, I'm going to go ahead and do my source files here, and I'm going to right-click, do add new item, and I'm going to create a CPP file, and this one's going to have the same name. It's going to be game object, and it's going to be .cpp. All right, and this is where we give the definition or the meat to all of the game objects we declare, or all the things we declare inside of our game object.h. So first thing I need to do is I got to pound include game object.h. This is how we know to associate the two files. All right. And then I'm going to start with my constructor. So I'm going to say game object, and I'm going to be giving the definition now of game object, the constructor. Now, a constructor is a function essentially that gets called every time we create an object of this class. Every time we create an object of this class, the constructor's job is to initialize all of our variables. It builds this object. Even though it's going to build this object to be empty, to have null values, there's a bunch of zeros and stuff like that, it's still preventing us from having errors where we try to access a variable that has no value and the compiler or the program crashes. All right. So the constructor is a nice default way of setting up all of our code to be safe. Right? So anytime my constructor, I'm going to say x equals 0, y equals 0. We know we're going to override these later, but for now, x equals 0, y equals 0, velocity x equals 0, velocity y equals 0. Now when I'm typing this out, you might be wondering to yourself, why am I using all zeros? The reason I'm using all zeros is because they're going to be more or less neutral values. I don't want to put some value in here because it's not going to be right anyway, and it might confuse someone using it. It might cause some bad errors, and it'd be really hard to track. So everything just gets set to 0. All right? Nice and easy, clean, neutral. And some of them we actually do want to be set to 0, like our frame counts and things like that. And then we got okay, what am I at? Frame width, frame height, animation columns, animation direction. All right, image equals null, and alive equals true, and collidable equals true. Okay, awesome. Now that's going to be everything we need for our constructor here. You can see by default, objects are alive, objects are collidable, images are null, everything else is 0. Okay, that's the way I want it. That's good defaults. All right. Now for my function, void game object, and you notice how I need to type the name of the class before the name of the method. That's just how C++ does it. Other languages you don't necessarily have to do that. C++ you do. All right, I'm gonna say if image does not equal null. So if we have an image there, then al destroy bitmap image. What I'm effectively doing is I'm making it so that I don't have to, in my main here, I don't need to have so many of these destroys. Every object is going to worry about its own cleanup. Okay, I can just create them and forget about them. I don't have to worry about all this cleanup. All right, so that's a really nice thing, because if you watch my previous videos, I forget to clean up all the time. So here we're going to do void game object init, and init is going to read in float. You know what? I'm just going to make this easier for me. I'm just going to copy this. I'm just going to copy this here for now. Actually, I'll copy these three like this, and drop a game object like that. Alright. So in this function here, all I'm simply going to say is game object x equals x, game object y equals y, game object velocity x equals velocity x, game object velocity y equals velocity y, game object direction x equals direction x. You might be wondering, why are we only doing these 1, 2, 3, 4, 5, 6, 7, 8 variables inside our init? Why aren't we doing all of them, you know? And the reason is not all of them, will need to be in here. The init is something that can get called over and over. Also, the init is something that is generic setup. All right, the specific setup will happen inside the specific classes. I do not need to do it here. So this is just limited to my more common variables. Awesome. Okay, so that's my init there. For my update, now basically, updating is pretty simple. Every game object in my game, not every game's gonna be this, but in my game, every game object. By the way, I don't need that virtual there. I don't need it here either. Every game object is going to update pretty much the same. All right, it's going to be x plus equals velocity x times direction x, and y plus equals velocity y times direction y. Alright, now what if I want an object that stands still? Well, that's easy. If I want an object that stands still, I just make sure that my direction x and my direction y is 0. And then every time it updates, it's not going to move. Or maybe it just doesn't have a velocity, But otherwise, it will move, and it'll move, in this manner. So I just do it here, and that way I don't have to do it in every other game object's update. It makes it nice and easy. Now rendering, on the other hand, every object's going to render its own way. So I'm going to leave this blank. The entire reason it exists is so I can make it virtual, and we'll talk about that. So we'll get there. Awesome. All right, I'm going to come back up to my H here, and I'm going to grab these last three. I'm just going to copy them. Come down here, paste them. Copy game object, and paste it at the end there. Don't need virtual. There, and there. If I have the semicolon here, it thinks I'm trying to redeclare it, and so that's why these have the red lines. As soon as I get rid of the semicolon and I put brackets, everything is fine. Okay, so for check collisions, this is basically that if statement, right? This is that if statement that's going to tell me whether or not two objects are overlapping. So I don't constantly have to use the methods. I'm going to simply declare float OX, no, that's not next, that's the one. OX is going to equal other object. Now, since we're using classes, you would normally do something like a dot notation. Since we're using pointers, we're going to use the line and arrow. We're going to say get X, and then we're going to do float Y. It's going to equal other object get Y, just like that. And int OBX, it's going to equal other object get bound X, and int OBY is going to equal other object get bound Y. There we go. Alright, so now we have those just stored in the variables, and I'm going to say if x plus bound X is greater than OX minus OBX, and X minus bound X is less than OX plus OBX, and Y plus bound Y is greater than OY minus OBY, and Y minus bound Y is less than OY plus OBY. That means we have collision, and that means I can just return true. Oh, that's not a semicolon. There we go. Return true, else return false. Alright, so this function is simply going to say, hey, do these two objects overlap? If they do, return true. If they don't, return false. Awesome. Great. This is going to save us a lot of code in our main and stuff like that by squirreling it away here inside of our game object. Once again, remember, we're putting a lot of work into game object, so our other objects become very easy to make. Alright. Collided, once again, only exists so that it can be a virtual function. I could put some code here, right, if I wanted there to be some basic collision, like bouncing or destruction or something like that. I don't. I want all my objects to collide in a different way, so I'm going to handle collision differently. So there we go. And then collidable. And collidable, like I was saying, is going to return both alive and collidable. So if both of these are true, it'll return true. If both of them are false, it'll return false. And if either one of them is false, it'll return false. It only returns true if both are true. So an object is only collidable if it's alive and it's collidable. Alright. So, I just want to go ahead and build this here. Obviously nothing's plugged in, the game's not going to play or anything. But I've built my game object class. Great. Okay, so that's going to pretty much do it for this video. We have our game object class, so we're going to see we can just start cranking out the other game objects, our ship, our bullets, our enemies, and that's all going to go pretty fast. And then we can just stick them all in the game and watch them just work. So it's actually really, really neat. Like I said, we're putting a lot of work on the front end with these videos. A lot of work goes into these base classes so that it's really easy, to add new classes and new functionality. It just plugs right in. It just takes a little bit of thought on the front end. So anyway, that's going to do it for this part. And in the next video, we're going to start making some of our more fun objects, the ones we're actually going to play with.